Take a strange road on Earth, and it becomes a space lesson. Why rough routes here can resemble movement problems on the Moon or Mars. Imagine a road that looks almost wrong. A desert track rippled like corrugated metal. A mountain road bending so sharply it feels folded into the cliff. A gravel route where every bump seems to arrive at the exact wrong moment. These places grab attention because they remind us that travel is not just about engines. It is about the ground itself. On a smooth highway, motion feels simple. Wheels. Roll brakes grip, and the route ahead is predictable. But strange roads reveal the hidden negotiation between a vehicle and a surface. Loose stones slide. Sand swallows tires. Ice reduces grip. Steep slopes. Steel, momentum. Even on Earth with air-weather repair crews and rescue vehicles nearby, the road can become the main challenge. That is the bridge to space. The Moon and Mars do not have roads in the way. We mean the word. They have terrain, dust, rock, slopes, craters, ridges and soft patches that may look harmless until a wheel meets them. A rover is not just driving across a landscape, it is testing every meter, asking whether the ground will hold slip, crumble, or trap it. This matters because space missions are built around movement. A rover that can travel farther can reach more rocks, more layers, and more clues about a world's past. Astronauts who can move safely across the lunar surface can carry tools, gather samples, and return to shelter with confidence. But every route has to respect the terrain. What scientists know is that surface texture, slope, and loose material can strongly affect mobility. What remains uncertain is how each patch of ground will behave before it is actually crossed. Images from orbit help rover cameras, help experience helps. But distant terrain is never as familiar as a road beneath your feet. That is why strange roads on Earth are more than curiosities. They are reminders that travel is physical, local, and sometimes unforgiving. Before humanity builds highways beyond Earth, it first has to learn how to read worlds with no roads at all. And that leads to the next question. What happens when the road is not strange, but alien? On the Moon or Mars, a rough route is not just uncomfortable. It can decide what a mission is able to do. A rover moving across another world has a very different relationship with the ground than a car on Earth. There is no paved lane, no roadside assistance, no quick human repair team standing nearby. On Mars, commands may take time to travel between Earth and the rover, so every movement must be planned carefully. On the Moon, astronauts may be closer in communication, but the terrain is still sharp, dusty, uneven, and exposed. The Moon is covered in regolith, a layer of broken rock and dust created by billions of years of impacts. It can be fine like powder, but also abrasive. It clings to surfaces, works into joints, and can make traction unpredictable. During the Apollo missions, astronauts used the lunar roving vehicle to cover more ground than walking alone would allow. It was a brilliant machine, but it still had to deal with slopes, craters, and a surface that had never been shaped for easy travel. Mars adds its own complications. It has rocks, sand dust, shallow drifts, ancient channels, crater rims, and slopes that may look gentle from far away, but become difficult at wheel level. Mars rovers move slowly, not because they are weak, but because careful driving protects the mission. A stuck wheel or a risky slope can limit years of science. The key idea is that terrain changes the cost of movement. On Earth, a bad road might cost fuel, time, or comfort. On another world, it can cost power, wheel life, scientific opportunity, or mission safety. A short path across loose sand may be worse than a longer path over firmer ground. A direct route toward an interesting rock may be rejected if the slope is too uncertain. Scientists and engineers study this through testing experience and careful observation. They can estimate risks, but they cannot remove all uncertainty. Soil can be layered. Rocks can be hidden. A surface that looks firm may behave differently under a wheel. That uncertainty is part of the fascination. A rover is both explorer and cautious driver. It turns alien ground into knowledge, one careful movement at a time. So, the real challenge is not only building a vehicle that can move, it is teaching it how to respect a landscape that has never had a road. The simplest lesson from strange roads and alien terrain is this movement depends on friction, slope, and route planning. Friction is the grip between a wheel and the ground. Too little grip, and the wheel spins without moving the vehicle forward. Too much resistance, especially in soft material, and the wheel can dig in. On Earth, drivers feel this when tyres struggle in mud, snow, gravel, or sand. On the Moon and Mars, engineers have to think about the same basic problem, but with unfamiliar dust, different gravity, and no easy recovery. If something goes wrong, slope is just as important. A hill changes how weight presses into the ground, how wheels grip, and how much energy is needed to climb. A slope does not have to look dramatic to matter. For a rover, a gentle rise covered in loose material may be more dangerous than a steeper surface with better support. For astronauts, slope affects balance, effort, visibility, and the safe return path. Then comes route planning. In space, exploration. The best route is not always the shortest. Engineers may choose a longer path because it avoids loose sand, sharp rocks, steep angles, or places where communication and sunlight are less favourable. Every planned drive is a compromise between curiosity and caution. This is why rover wheels are not ordinary tyres. They are designed for strength, grip, low weight, and survival in harsh conditions. Suspensions are built to keep contact with uneven ground. Cameras and sensors help the vehicle understand what lies ahead. Software can assist with local decisions, while teams on Earth study the next safe move. What is known is the principle: a successful space vehicle must work with the terrain, not against it. What is still uncertain mission by mission is exactly how each new landscape will behave. Every world has its own texture. Every crater ridge and plain has its own driving rules. That is the memorable takeaway. A road is not just a line between two places. It is a relationship between a machine and a surface. On Earth, strange roads make us slow down and pay attention. On the Moon and Mars, that same caution becomes a survival skill, a science tool, and a quiet form of exploration.